We're going to look at solving exponential equations. Exponential equations just means you have an equation where your exponent happens to have a variable. Okay, so first looking at this stuff, definitely confusing. But the whole idea here is we need to break these problems up into numbers that we can manage a little more easily. So I have 6 to the x power. That's great. I need to make this 216 also 6 to a power before I can do anything. So I'm hoping that it works, but in this case, 6 times 6 is 36. 36 times 6 does give us 216. We're using 6 3 times. So if I were to rewrite this, 6x equals 6 to the third power. That 216, we just wanted to make it look differently. Now, since the base is the same, 6 and 6, I can kind of ignore them and only focus my attention right there. I'm going to create an equation with those exponents. And in this case, x equals 3, there's nothing else to do. We're done. We call it a day. Move on with life. Does it get hard? Does it get more difficult when you have more going on, when you have a binomial going on as an exponent? Not necessarily. We need to go and we want to try and rewrite the problem so they both have the same base. Well, I see 144. I know when I see 144, I think 12 times 12. I get 12 multiplied 2 times. So let's rewrite this. 12, 2x plus 3 equals 12 to the second power. So again, 144, 12 to the second power, same exact value. They just look a little different. Now, our base is the same. Let's ignore it and focus only on the exponents. We're going to now create an equation just with this portion. So 2x plus 3 equals 2. Now I want to solve this like I did any other equation. Minus 3, 2x equals negative 1. Divide by 2's, gone. X equals negative 1/2. We have a fraction, it's negative. Can we have that? Yeah, who cares, whatever. We figured out what that missing x was, negative 1/2. Now, the more complicated version of all of this is I need to rewrite 25 because 25 here, it's too big of a number. I want to see if I can make it smaller, but it messes things up because that's where our exponent's at. So I see a 5, I see 25, I know I could just say 5 times 5, so 5 squared is 25. So I'm going to take this number and rewrite it. And instead of 25, I'm going to say 5 squared. I'm going to put it in parentheses just to say this is my number because now I have an exponent, x minus 1. Okay? On the other side, I have a plain old 5. We're dealing with exponential equations. We need exponents. I don't see one here, but that's fine. We still have something. If you do not see an exponent, it's that magic one that you don't always have to write. Now, our bases are the same. Let's ignore them and only focus on the exponents. Now, here's where it gets a little weird. I need to take, I have to combine this 2 with the x minus 1. And what I'm going to do is distribute that 2 to everything. So instead, we now get 2x and then minus 2 equals our other side, just 1. Now get x alone. Inverse operations, plus 2, 2x equals 3, divide 3 over 2. It's a fraction. Who cares? We figured out what x is. That's solving exponential equations.